Hi all, welcome back to another lecture of DBMS, and in this lecture we will learn about types of databases. So we have few basic types, basically five mainly different types of databases, on which first is relational database, second is NoSQL, third is hierarchical, fourth is network database, and fifth is object oriented database. So let's begin with this lecture, and let's start with the very first type of database, which is relational. So here we know that on what basis we are differentiating these different types of database, basically on the basis of structure. The way how we want to maintain the data in different structures, we have categorized these database into those different types. Very first is relational database, where we are organizing the data in form of rows and columns. So this is how it will look like, and every row will have entries of data with the columns termed as parameter for it. So for example, let's suppose we have name as one column, age as another column, and Aadhaar card number is another column. And let's suppose we have name A, age 20, Aadhaar number, then name B, age 22, then Aadhaar number. So this row will be considered as, each row will be considered as data entry, and each column will be considered as the attribute called parameter. So in relational database, we have a fixed number of columns. In case of NoSQL database, we don't have such fixed things. Like for A, it might happen it has age and it has address. For B, it might happen it has Aadhaar number. So here number of columns are not fixed. Even structures are not fixed. So we go for NoSQL database, where MongoDB is the example of NoSQL database. Another is hierarchical database. So in this database are organized in tree-like structure. So basically we have a parent and we have many, the parent can have multiple child. So it has one to many relationship. Why? Because one parent can have multiple child, but every child has only one dedicated parent to it. IBM's information management system, that is IMS, is the example of hierarchical database. Next is network database. So it is similar to hierarchical, but instead of one to many mapping, we go for many to many relationship, and it looks like a graph, right? So here it can have many to many relationship. IDS, which is integrated data store, is the example of network database. Another is object oriented programming, object oriented database. So like how we create object in OOPS, the similar way we will store our data in this format. So database that store data in the form of object, similar to object oriented programming language. And object DB, object database, is the example of object oriented database. So these were the 5 different types of database which we have learned in short. Now let's learn in more depth. First is relational database. So basically here we allow data to be stored systematically, and these data to be easily retrieved, filtered, sorted, and updated efficiently. So here you can see this table, right? So we have transaction ID, customer ID, product ID, and purchase date. So we have every column here, and purchase ID we have got it from the product table, right? Product ID. So product ID we have got from product table, where product ID in both this transaction table and product table are same. So on this basis we have a relation with this table. And if we want for 389 what is the product name and what is the price, then with this product ID we can go in the product table and fetch those data. Similarly, customer ID is there in customer table, and that is unique. And with the customer ID we can fetch the first name and last name from the customer table to the transaction table. So this is basically the relation between these different tables, and here we have data entry of the same structure, of the same format. And basically we use is SQL query to manage, to retrieve data. Example of or use cases of this relation databases in banking system, in e-commerce platform, and in enterprise application we go with this SQL, which is relational database. Next is NoSQL database. So here we don't have the structured format, so it is also known as unstructured, semi-structured, or non-relational database. We don't have here fixed schema. We have dynamic. We allow dynamic data structure here, and no predefined schema is required, which makes it easy to modify the structure of data and requirements change. Real-time analytics, social network, IoT data, and content management are few of its use cases. And also it stores, instead of like how relational database was storing in a table in row and column format, here we save it as a key and value format, like how we keep in hash map. So we will having a key and we will have the value, where the structure of value is not defined. It can be integer, it can be string, it can be again a hash map, it can be anything. The structure is not defined, but the key should be unique, because on that basis itself we are going to fetch our data entry from the database. Next is column family. Basically here data is stored in columns. So like how in relational database we were storing our data in rows, here we will store our data in the column format. And for every column we have the column nested column inside it. So that is how we store the NoSQL data entry in as a column family. Next is graph database. So here database is represented as nodes. So this is called data. It is represented as node, and the edge is nothing but the relationship between those two nodes. Document database. So we store data in document format. So usually we take JSON, BSON or XML file, and each document is self-contained unit that can contain various types of data. So these were the few characteristics about the NoSQL database, which is MongoDB. Basically the example of NoSQL is MongoDB, which we use in large amount, and in most of the cases we use MongoDB. So this is how the structure of NoSQL database looks like. Now let's move on to hierarchical database. So we know that here we save the data in the tree format, basically parent-child relationship, and that is one-to-many relationship. Data is accessed via predefined path, similar to navigating in a directory. So if how in one folder you have different files saved, right? And when you want to go on those files, okay, like how you navigate into your directory, similarly you will be navigating here also. So let's suppose DSA questions, okay. So if in the normal file system, if you will save these things, so how will you save? You will save like one after another, right? Bubble sort, selection sort, linear search, binary search, and so on, right? But fetching in that case will be difficult. In this case, inside the DSA question, if we know that selection sort is a part of sorting algorithm and not searching and graph algorithm, then after DSA we'll go in sorting algorithm and then we will search the selection sort. So fetching is also easy here, and we fetch in the same way like how we navigate in the directory for getting the files. So this is all about hierarchical database. And now network database, if we'll talk about, it is similar to hierarchical, but instead of one to many, it gives many to many relationship. Okay, and instead of tree we go for graph here, because in a graph we have multiple and many to many relationships. Okay, so data is stored in a graph structure where each record node, like this is called record, right? And each connected to others, like how each record is connected to others via links, this is called edges, and it allow more flexibility. And network database supports dynamic flexible relations, which makes it easier to adapt and changes in models. So network database allows and makes the relationship more flexible, which is actually making the database retrieval very easy. So you can see data server, there are a lot of data server, and this through network they how it is connected, and it has many to many relationship also. It means one database can communicate with another database also via this network database. So this was all about the network database. Now let's move on to the last database, which is object oriented database. So in this format, instead of saving our data in the tabular form, or instead of saving our data in a key value pair or tree or graph like structure, we go with the object creation. So object-oriented database are very similar to how we actually save our objects in the object-oriented programming language, and this allows for a natural alignment between the data structure and application logic. So what happens here, you can see this person is the class, parent class, okay, and student, employee and teacher are the child inherited from the parent. So this allows all the parameters and attributes which was there common for the person, which was a parent. These properties can be inherited to student, employee or teacher also. So object can inherit attributes, behaviors from parent class, enabling code reuse and reducing redundancy. So example, you can see both student and teacher can inherit the common properties like name, date of birth and address, along with their individual attributes like admin ID, role and department. So this is another type of database which we use: object-oriented, network database, hierarchical, NoSQL, and relational database. So that was all about the whole lecture. I hope you learned. Now let's meet in another lecture. Till then, take care of yourself and your family too.